An AI agent looked at its own scoring system, found a whole category of inputs with no predictive value, and removed them. That is the claim at the center of a new Abacus AI AutoBots demonstration. If accurate, the important part is not that the agent edited a spreadsheet or changed a prompt. It is that the system closed its own improvement loop.
Here is the architecture described in the demonstration. One model performs the work. A separate evaluator scores the result against a hard metric. The system records what happened, updates a goal-specific playbook, and runs again on schedule. That is not a model spontaneously becoming more intelligent. It is bounded operational learning.
The sales example is the strongest claim. The source reports precision rising from 22 to 79 across 1,075 leads. It says the agent removed low-value signals, found a fuzzy matching bug, documented the failure, and patched the scoring process. Those are vendor demo metrics, not independent validation.
The coding example is more interesting for its controls. Production was off limits. The agent could not close a ticket by itself. A patch only moved to testing after the linter and build passed, and a human still approved every ticket. That is the difference between autonomous work and uncontrolled authority.
The thumbnail agent produced the most scientifically useful result. Nothing happened. The click-through rate stayed flat at 5.1%. Instead of manufacturing a victory, the agent waited for enough exposure before declaring a winner. An honest plateau is stronger evidence than a perfect upward graph.
The paper trading example needs the most restraint. It used fake money and real market data. One early loss was followed by a 66.7% win rate later that day, while the portfolio remained near baseline. That is an experiment in feedback loops, not evidence of a profitable trading strategy.
The real product is the cycle. Measure, evaluate, update, repeat. But every cycle inherits the weaknesses of its metric. A bad evaluator can reward the wrong behavior. A narrow metric can hide harm. Small samples can create fake confidence. And an agent can optimize the score instead of the real goal.
That is why self-improving agents need more than memory. They need version goals, evaluator separation, reproducible metrics, permission boundaries, rollback, audit receipts, and verified continuity across every run. Otherwise, the system may improve perfectly in the wrong direction.
Our verdict: the architecture is real and important. The reported demonstrations are promising but vendor-controlled and early. This is not AGI, and it is not the underlying foundation model retraining itself. It is something more practical. A persistent agent wrapped in a measurable improvement loop. The loop is the product.